Introduction to the winged mills. Suppose you want to pump water or air far from the grid. To use steady but light winds needs a ton of multi-blade wind pump and a crane to put it 30 feet up. Consider instead our uni-blade winged mill of much lower weight. You solo can install it to pump much more in soft winds at much less cost. Our wing blade oscillates about a low pivot to sweep a large and high sector of wind without the cost and danger of the fan mill's tall tower. Its low bearings are much easier and safer to lubricate. In light winds, the heavy tail of our wing falls from highest to lowest. But this 10-knot wind is damping the fall in half, safely limiting the wing's angle and lift. Higher winds damp out the angle entirely. Thus our wing is feathering safely to this 15-knot blast. But to avoid too much drag and RPM, a fan mill needs extra mechanisms to yaw and break it sideways to a gale. A winged mill can always be stopped by just pulling the wire to the red lever to center the wing. Then the pendulum can be locked for climbing to inspect the winch. Any overswing of the pendulum also tensions the wire to reduce the wing angle and so its drive. Should the pump valves fail and inertia swing the pendulum even further, the yellow latch catches and holds it safe. This signals for miles to fix the pump. Instead, a rotor just keeps on cranking a broken pump, fooling the farmer and wearing away. When a hurricane with its flying debris is forecast, remove some counterweight, disconnect the winch and lever, and overswing the pendulum to remove the wing easily by hand from ground level. Then the bare upper pendulum serves as a gin pole for raising and lowering our monopile base with only a hand cable puller. The blue cam track presses the wheel, angling an upright wing. Then the wing lift rolls the unlocked pendulum until the wheel falls over the cusp to fast start the wing. Excess winds blow the sprung brown board and so this starting cam back beyond all contact. But a fan mill can't turn over its crank to start in the best wind for its stroke. For a typical wind variation, it can only usefully pump just 1/10 of the work of a windmill with an ideal load. The oscillating uniblade is a much better match of the ever-varying wind to single-acting pumps against fixed pressure. The pump stroke of our winch, with its spiral coils, varies strongly with the swing, not loading a starting swing in only 2 knots, but still absorbing all the wind power swept in a big swing in a good wind. Winged stands for wind, wing, winding. Comparing pumped watts versus wind speed, the winged mills pump twice as much in light winds as the air motor multi-blade, reducing the size and big extra cost of a sealed reservoir for potable water. Storing air is cheaper, but loses a quarter of the pump work, and the fan mill crank sticks even harder, whereas our auxiliary air cylinder easily pumps into the white tank with the PSI relieved at 145 or 10 atmospheres. For side battery charging, the ring gear drives its ratchet starter pinion on the alternator shaft, with a pickup coil sensing rotor speed to switch the field on. This add-on can be homemade for 1/5 of the cost of a separate wind charger with its alternator rewind. Solar electric pumping is far too expensive for more than nominal duty, whilst the winged mills pump enough to be used for trickle or furrow irrigation of a small farm. Nothing solar panels, submersible motors, or rotary pumps can be made by artisans, but the winged mill is simple and cheap to produce. The wing's wood frame is a strong 40-pound truss of light and durable western red cedar. The woven polyethylene fabric is wrapped around it, stapled at the trailing edge, and heat shrunk. With a coat of aluminum paint rolled on, this very cheap cover will last at least 5 years in the sun. The pendulum axle is a low-cost threaded pipe with used truck bearings. The counterweight can be a steel box filled with soil. The tail vanes which yaw the wing and pendulum into the wind are whole sheets of plywood or metal roofing. Our pumps don't yaw, they're combined piston, valve, and seal. Let's look in detail at the different pumps and bases for ponds and wells that make the uni-blade pendulum more versatile than the multi-blade rotor. FLO'Pump base, FP. On a small lake, the floating pump can be drifted to the shore needing the water and anchored to yaw with the wind. If there is enough wind to ripple the water, the FP pumps, as its submerged cylinder never loses prime. Whereas a fan mill fixed on the shore needs more wind and much more pipe to irrigate the fields around the lake. Its suction pump can lose prime any time the wind lulls. Nor would floating it eliminate the yaw bearing it still needs for turning sideways to storms. If our wind swings too far, its tip rod picks up water from the pond, making it less tail heavy to angle and swing less. The whole base floats around the gray PVC pipe. Above it, 3 heavy anchor ropes and output pipe to shore. Inside the submerged white half of the PVC, the drag of the heavy piston falling through the water sucks air into the top of this cylinder through the small white snifter valve. On the upstroke, the piston pushes this air, then water, through the red flap valve in the divider. The upper PVC is sealed into an annular chamber to collect the air to cushion the water output through the big lower side port. Here, 1 gallon per second blowing 100 yards into a 20-foot higher pond, or static 10 psi. When the chamber water level drops the pink float, its valve outlets the excess air through the garden hose, here as submerged bubbles. This air, up to 1/3 of the total intake, helps to aerate and destratify the pond to improve its water quality. For injection in deepish ponds, air from the auxiliary air cylinder can be stored inside steel pressure cylinders, doubling as the FP's pontoons. Otherwise, the flotation can be styrofoam for moving the FP between small ponds, or just raw logs for a bigger lake with a steady wind direction. For its cost, the floating pump of water out and air in is the simplest, most powerful pond windmill ever. Flutter well, FW, and pipe pump for drilled wells. For potable water and in arid zones, the same winged mill, wing and pendulum can be used to pump groundwater in lighter winds more economically than the multi-blade. The Flutter well monopile mounts directly on the grouted-in steel well casing with a hinge joint for very easy raising and lowering, whereas a multi-blade needs concrete foundations for each power leg. The coiling of the pump belt permits very long strokes through the yaw taper roller bearing, overcoming any stretch and reducing the diameter of the piston and the clearing diameter of the poly drop pipe. Whereas a stroke cranked by a rotor must be much smaller to pass through its yaw hole and not to descend faster than it can fall. Then, transmitting it down the well needs steel pump rods to a piston wider than the steel drop pipe. For maintenance, many hands are needed to lift and hold each very heavy series while carefully unscrewing each emerging length of rod and pipe. The hydraulic return of our pipe pumps is fast enough for the large FW strokes or for treadling the yard pump by 1 adult or 2 children. Just pull our continuous pump wire up past its normal stroke to release the water column and retrieve all the seals and valves. So emptied, the yard pump's polyethylene drop pipe is very easy to pull. Or, after changing worn seals, just lower the pipe plunger down the drop pipe to resume pumping instantly. A winged mill on high exposed ground can pull the pump wire sideways from a well in a ravine or near buildings or trees. A treadle inside a heated winter cabin can pull low stretch rope through a buried side pipe. The pulley in the T comes out for removing the yard pump plunger at the wellhead, and the cabin pulley cage is also a force fit in the elbow. The plunger rests below its normal stroke on a clean, wear-free static seal that can retain the water column for weeks between pumpings. Here, the FW pumps the clean, potable groundwater 20 feet high before draining it back to this low-yield test well. The vinyl sheathed stainless pump wire slides through a standard bearing seal at the wellhead. This small compliance seal leaks less with less friction and expense than the multi-blade stuffing box and polished rigid pump rod. With a snifter, check valve, and tubeless surge tank above the wellhead, the pipe pump then adds 1/4 air to its water stroke for smooth 40 psi streams of tire air and hose water from the tank top and bottom. To sum up, the pipe pump is the easiest deep well pump ever to install and maintain, especially with the Flutter well. The windmill water pumps also sniffed air for cushioning and output, and optionally side pump air to 150 psi and charge 12-volt battery, all in lighter winds at less cost than wind rotors.